All right, so the next thing we're going to use our graphing calculators to solve will be systems of equations, which are sets of equations in which the variables have the same meaning. In your past, we've done them by two algebraic ways, substitution and elimination. You also did them with graphing, but we haven't done that with a while. But now that we have a graphing calculator, we're back to graphing. We're going to graph systems of equations. And the solution, after you graph your equations, is the intersection point. So since we know how to use our calculators to find intersections, we can now find solutions to systems. This example, nicely graphed, has a solution of -4, -1. When you're giving a system's solution, you want to give the x and the y that you can find on your calculator. For example. All right, so here's a system. Now this one starts off a little easier for us because it begins with two equations that are already y equals. So in y1 we can put -3x plus 4. And in y2 we can put the 1/3 x minus 1. Okay, and then we'll see what happens. Okay, so remember, if you have a Casio, once you graph your two lines, you'll see where they intersect. You'll press F5 for solving, G-solve, and F5 for intersection, and you'll find your intersection. On the TI, 83 or 84, you will see where they cross, and then you'll type second and trace to get into the calculate menu. You'll choose number 5, which is intersection, and then you have to hit enter 3 times because you have to answer 3 questions. Okay, and with this screenshot from my Casio, you can see that my intersection appears here at the bottom. It's right there where the two lines cross. So that's my solution. My solution is 1.5 for x, comma, -0.5 for y. Okay, so one more example. Now this equation doesn't have either equation written for y equals. So we'll have to rewrite both. So we'll start with let's not start with that fat of a pen. Let's see. Let's start with -3x minus y equals 12. First we move the x's when we're in standard form, so we'll add 3x. And then we'll have -y equals 12 plus 3x. And so we have to divide by -1 to get y by itself. Remember, this will be what goes in y1. And we want to put parentheses around the top of the fraction so the calculator knows that everything on the top of the fraction needs to be divided by -1. Okay, second equation. Well, let's make this a little wider. So we'll have y plus 6 equals 1/2 times x minus 3.5. This would be a perfect example of why you don't really want to distribute, because 1/2 times 3.5 would be messy. So make the calculator think for you. Just subtract your 6 from the end over here. And so y2 can contain 1/2 times x minus 3.5 minus 6. So I'm going to put this in my y1 and this in my y2, and then I'm going to find my intersection. Okay, so there's a screenshot from my calculator. As you can see, the solutions down here at the bottom. Yes, this is what it looks like on a Casio, but the same solution will be there on a TI. So my solution is negative 1.214 for x and negative 8.357 for y. There's the solution to my system.